All right, the last visualization library that we're going to talk about is the Seaborn. So for Seaborn, remember, we have to make sure that the Seaborn is already installed on our computer. So to just quickly show you how to do that, if you're on a Mac, open your terminal. If you're on a Windows, open your command window, right? If I do CMD, it's open a command window, and then wherever it is, it really doesn't matter which directory it is. If I do pip install, and Seaborn. It's going to install Seaborn into your Python package. This command is going to work only if when you install the Python through Anaconda and you check that box that I talked about in the installation video. Otherwise, you have to open Anaconda Navigator, not this one. Anaconda, the command window, not this one. Okay. So it says that okay, Seaborn is already set, the requirements is already satisfied here. It's already installed on my computer. Okay, as you can see, this is the location. This is the user, my last name, Anaconda 3, libraries, and this is where the package is sitting. All right, so now we're going to talk about in the Seaborn, we will talk about distribution plots, categorical plots, heat maps, facet grids, regression plots, and etc. Okay, and even though this notebook is going to be about Seaborn visualization, but I'm importing the matplotlib.py plot as well, because as I said in the earlier video, sometimes we use a combination of the visualization libraries. And so this is PLT, and for Seaborn, we're going to use SNS. Again, this is a convention. People that will use SNS for Seaborn. PLT, if you do PLT, everybody knows that you're talking about matplotlib.py plot. Okay. Again, this should be fast. Yeah, so already the libraries are imported now. Now, so some libraries, I think, actually, this is a time to talk about it. Some libraries that we install on our computer, they come with their own built-in data sets. So why do they do that? They do it because you want to play around with some data set. They don't want you to, and they want to provide some templates, right? So some documentation, some user guide. Say that, and they want to make sure that you can replicate their graph. So I say that, okay, use our own data sets, which are available in the let's say Seaborn library, then try to replicate whatever we have in our documentation. So if you want to see the name of those data set available in Seaborn, for example, you can say SNS dot, and as when I do SNS dot, press tab, there are lots of things that I can do with Seaborn. One of those things, one of those functions is Getsdataset Name. So basically tell me the name of the data sets that are available in this Seaborn library. So these are the name of the data sets available. For example, we have mile per gallon. This mile per gallon is the same as, for those guys who have worked with R, this is exactly the same data set which is available in R, mile per gallon. And yeah, for example, it has data set about penguins, planets, tips, Titanic, who survived, who died, things like that. Now we're gonna work with some of those built-in data sets. So for example, I want to come up with a data frame, call it MPG. You can call it DF, whatever. I call it MPG, mile per gallon, and says that SNS dot load that data set. What was the name of data set? MPG. Okay. Again, I could have called it DF. It really doesn't matter. So I call it mile per gallon. Now the data is imported. I want to look at the head of the data set. So this is the head of the data set. So we have mile per gallon, cylinders, displacement, horsepower, and etc. Right? And of course, the name of the vehicle. Then we can look at the information of that data set. If I do mile per gallon info, so all of them are fine. Float, integer. Well, original name, these are objects. So again, later on in the course, we're going to talk about those objects. Usually we have to transform objects to something meaningful because object is very general. So we have to make them categorical, for example, make them dummies, for example, and things like that. Okay. Okay. Now let's start with some plots. We're going to start with distribution plots, right? If I do SNS.displot, so I want to look at the distribution plot of, let's say, mile per gallon. Mile per gallon, well, I think if I rename this mile per gallon to DF, it's better. Yeah. it's less confusing. So from that data frame, I want to look at mile per gallon and then just simply plot the distribution plot, right? And I can do PLT show if I don't like this line. Okay, so this is a distribution for mile per gallon. Then I can do distribution plot, and then mile per gallon, I can say KDE is equal to false, because by default, I can see a KDE as well. This is a distribution function, right? I don't want to see that. So I say, okay, KDE is equal to false. I can change the number of beans. I can change the color. Oh, again, it's going to be something like that. Again, if you don't like this line, you can do plt.show. Then now we're going to see the power of the Seaborn. So it's going to shine. So let me actually give you full size. So here's how powerful Seaborn is, and it's very, very comparable to ggplot2 package in R, right? So imagine I wanted to look at, let me actually show you the data frame again, the head of the data set. For example, I want to plot mile per gallon versus horsepower, right? Mile per gallon versus horsepower. And not surprisingly, the more powerful the car is, the mile per gallon is going to be less, right? So it's going to consume, it's going to be more consuming vehicle, right? So there's going to be a relationship like this. And then let me actually do it in 2 steps, show you 2 steps. So I do sns.scatterplot. I pass, well, let's pull up a contextual help. You see, by default, the first argument is x. So if I type x is equal to something, is equal to mile per gallon, it really mile per gallon. It really doesn't matter if I type in this x or not, because I know that the first argument is x. So if I do it like this or this, that's the same. Then the second one is going to be horsepower, for example, horsepower. If I plot this, oh, so there's most probably some misspelling somewhere I'm doing. Oh, I didn't pass a data set, right? So I just said that, okay, X is mile per gallon, Y is horsepower. So what is a data set? So we have to pass the data as well. And now because data is down here, I cannot say simply df, because I have to say the data is equal to df. Okay, now if I plot that, so this is, let's do plt.show. This is very expected, right? The more powerful the car is, the more consumption it has, so lower mile per gallon. Okay, we are talking about this. The less powerful the car, lower consumption, the higher mile per gallon, right? Now let's play around with this. We say that, and this is where Seaborn is going to, as I said, shine in terms of power. Let's say, I want to say, for example, change the hue, the colors of these dots by the number of cylinders, right? So not surprisingly, I expect to see more, the high cylinder vehicles here and low cylinder vehicles here, right? Let's see if that's the case. So how do I do that? We're going to say change hue is equal to a name of a variable in your data frame, right? So what do I have? I have cylinder. I can change that by origin, maybe. I can change it by, I'm looking for some categorical variable. Acceleration, model year, maybe. Yeah, model year is a good one. So I can think of hue for different, you play around with that. So here I'm going to do cylinders. So if I do that, not surprisingly, so this is, it says that, okay, here, the more the powerful cars with higher horsepowers, the cylinder is higher, right? It's 8-ish here, 6-ish here, 4, and maybe very few vehicles with 2-cylinder, but basically most of them 4. Okay, so this is very powerful visualization, right? I can even go further. I can say, you know what? Change the size of these circles. So we change the color by hue. Now we say change the size of those circles by their weight. So what do you expect to see? Here is going to be heavier one, right? Here is going to be light. So here, this circle is going to be higher and bigger, right? So if I change the size by weight, how is it spelled in the data set? Okay, a small letter, W-E-I-G-H-T. So this is now sorted by both cylinders. So the colors are cylinder, and the weights are, the size are weights, right? So see how powerful this visualization is? And this is what we replicated down here. So I'm going to go ahead and drop this one. And now I want to make it even bigger. So I'm going to say, okay, let's change the size of it. plt.figure and fig size is equal to, we want to make it, let's say 10. We're going to try by 10 by 6. Okay, 10 by 6 is, yeah, we can do 10 by even larger height, 8. Okay, so this is a very, very powerful visualization. If I wanted to plot something like this using Matplotlib or Pandas, it was not impossible, but I had to write it in no, I couldn't do it in one line of code like SNS. So that's the power of Seaborn package, Seaborn libraries, right? As I said, the newer libraries come to help us to code easier, right? As we move on, the coding is becoming easier and easier and easier because the new libraries are easier to work with. Look at that. I can do this beautiful scatter plot with different categorization by simply one line. Okay, so that was an example. Then let's quickly go over other examples. So I can do joint plot. X is weight, Y is mile per gallon, data is mpg. So here's a joint plot. Basically, I can see the distribution of mile per gallon and weight at the same time with the scatter plot. So this is right skewed, this is left skewed, and the scatter plot, there's a negative relationship between mile per gallon and weight, which makes sense. The heavier the vehicle, the higher consumption, lower mile per gallon. I can do a joint plot. So that was also a joint plot, but I can change the type. So for example, I say kite is equal to hex. This now, instead of a scatter plot, we're going to look at the hex. So hex automatically has, so the darker the points is, the more observation is here. So see, here is busy, maybe here is busy. See, here the data is busy. So that's, again, these are all different conventional plots that we can use. Then I can say, give me, so this is also very interesting. For kite, I say, give me the regression line. Okay, so this is really, really interesting. Give me the regression line. So there's a negative relationship between the two. I can look at the, again, you can play around with these things. In machine learning, we don't get the luxury to necessarily plot things in 2D when it comes to regression, because most of the time you're controlling for, I don't know, 20, 30, 40 features or exponential variables. So, but it is fun to know that these options are available in Seaborn package. But maybe sometimes you want to see the relationship between the target variable and one specific feature or exponential variable. So that's when you can use these kind of things. Pair plot. So pair plot is going to be a very super powerful one, and we are going to use it for the course. So pair plot will plot the pairwise relationship across an entire data frame, right? So let's say I have, well, let's look at this data frame, right? So I have 1, 2, 3, 4, 5, 6, 7. Well, I'm not going to use origin. I'm not going to use name. So let's select some of them. So I'm going to say that, okay, make a new data frame. I have to change these. Because sorry, I have to change all these MPGs to DF. Otherwise, my code is not going to, the one that I'm going to push to my repository is not going to work, because remember, we changed those things. So this is going to be DF. Next one is going to be DF. I want to make sure that these codes are replicable. We can do them. DF. Now, if I look at the head of the DF, now I'm going to replace the DF. Just replace it with some other data frame. It really doesn't matter. I just keep the name DF. So DF is going to be a combination of, let's say, 3 variables: mile per gallon, cylinder, and weight. Look at the head of it. So this is my new data frame now. And now if I do SNS pair plot past the entire data frame, so it's going to give you, actually, let me go ahead and maybe change the size now. Show. And it's going to show me the pairwise relationship between the two variables: mile per gallon, cylinders, weight, mile per gallon, cylinder, weights, right? So basically, mile per gallon weight, negative relationship; mile per gallon and cylinder, again, somehow negative relationship, which is not surprisingly. Mile per gallon. So for this one, because mile per gallon and mile per gallon, we're talking about the same variables, basically it's going to plot the distribution for you. So it's going to be distribution, distribution, distribution. for mile per gallon, cylinder, and weight. And then the rest of them are pair correlations between the two. Okay, so this is very powerful. Before running your model, you have some sort of ideas that what's the relationship between the variables in your data. Then we can do value count. So for example, I want to see my cylinder. How many cylinders I have? I have 4, 8, 6, 3, 5, and these are 5-cylinder. Do we have a vehicle with 3 cylinders? It seems to be we have. So we have vehicles with 3 cylinders and 5 cylinders, but only 4 of them are with 3 cylinders and 3 of them are with 5-cylinder or cylinder. Okay, now we can play around with that pair plot. So let me speed up a little bit because I want to keep this video short as well. And we're going to talk about Seaborn package library later on in the course. So for example, I can play with the hue to just change the colors based on cylinder. And the palette is basically the coloring in general. So I'm going to use cool, warm. You can Google for different palettes. So for example, we can do blue and green and things like that. Okay. And again, these are warnings. We like warnings, right? So I could have run a one-line code at the beginning of the notebook to avoid these warnings, but I don't do that because I want to see what are the warnings. Usually the warnings are talking about the future releases of the packages and things like that. Okay. So I want to see what's inside the warnings. So here is the same pair plot, but now based on different colors for different cylinders. This is very powerful. Okay, second type of plots is categorical plots. So remember, our cylinder is a categorical variable. I want to look at the cylinders versus mile per gallon, and I want to look at their box plot. So here's how we do box plot. Here is how, again, just make sure you read these things on your at your own pace. It's very straightforward. So I can look at the basically look at the bar plot. This is box plot. This is bar plot, and then we can have count plots. Remember, we have value counts. We show that there was only 3 of them, or 4 of them was with 3-cylinder, 3 of them with 5 cylinders, something like that. So this is the visualization of that count plot. And then we're gonna, the third type is going to be heat map. This is also something useful. And for example, now I can say, I have to change all these things. Yeah, but I make a mistake from the beginning. Well, now I will fix this notebook and push it to my repository, because now if I use df, it's not gonna work. If I do df, remember, we changed the df things. So cylinder and mile per gallon were still there. So here, cylinder, mile per gallon are still there. This is fine. It works. It works for this one, but it doesn't work for the correlation. See, the correlation is going to be, because we are in the df, I only have 3 variables. But in the mile per gallon, I have all the variables. So this is a correlation between all the variables with a pair correlation between all variables, right? So of course, in the diagonal, we are going to see 1 because the correlation between x and x is 1, cylinder and cylinder is 1. And off diagonals are the correlations, right? And of course, it's symmetric. So for example, the correlation between mile per gallon and cylinder is minus 0.77. Cylinder and mile per gallon is minus 0.77. So not surprisingly, this is going to be symmetric. Okay, I just wanted to show you that what does this correlation function doing to your data frame? And now I can use that correlation function into a heat map. So if I do SNS heat map, and then this is basically CMap, basically the coloring palette, annotation is equal to true. And it's, if I just remove this annotation, see, I don't see the correlation number inside it, but if I do annotation is equal to true, I can see the correlation number inside it as well. So I'm going to do plt.show. I think it is a good idea to change the size, fix figure, fix size. Make this one bigger and bigger. Let's do 10 by 8. Okay, so this is our heat map. Again, this is going to be super helpful when you're doing our regression analysis. But in machine learning, we move beyond linear regression. But for the first set of models, which is linear regression, we're going to revisit these things again. Okay, so the last one, this is a little more advanced. So And we are not going to use it for the course, but for the sake of argument, I put it here. Just feel free to explore them. What is the idea of facet grid? So the facet grid is we're going to divide our grids into different facets. So for you, we can say, okay, let's look at an example. This mile per gallon data set that we have, let's say we want to look at the value counts of origins, right? So it seems that the cars are either come from USA, Japan, or Europe, right? Now, let's play around with what is this facet doing. So I'm going to say, let's save it as an object. This can be anything. Again, it's a name. Just as long as there's no space, it's not going to complain. Let's save an object. And in that object, we're going to use the facet grid. So in the facet grid, again, there are some features here we have in the facet grid. It says that, okay, what is your data set? MPG. What color, what are the columns? We say, okay, this is column, this is row. I say in the columns, I want to use cylinder. So if you see, I have the one column here, cylinder 3, one column here, cylinder 4, one column here, cylinder 5, and etc. Rows are origins. So I want to see weight, origins. So for example, the first one is USA, the second one Japan, the third one Europe, right? So the origins on the, let me actually, this should be, yeah. The origins on the used as rows and columns are cylinder. Let me actually make it more simple. Let's start with only rows. Okay. Now I only have 3 rows, right? Because this is USA, Japan, and Europe. All right. If I do row and column, sorry, if I do row and column, or let's actually look at the columns only. I have, see, 4 to 5, 1, 2, 3, 4, 5 different columns, which is based on the cylinders. Now I can have a combination of the two, both based on rows and columns. So you see how powerful is that? And then when you define your facet grid, basically you told it Python that what is your column, what are the rows that you want to see in this facet grid actually. Then you pass the map function. So you say, okay, take this object, map. What do you want to map to? I want to map a scatter plot. So this can be histogram, scatter plot, etc. X is mile per gallon, and Y is weight. Okay. So this is one example. There's another example. Let's basically add the hue function as well. So I'm going to say that, okay, let's keep the columns as cylinder and change the hue to origin. So now tell me that change the coloring based on the origin, the country of origin, right? And basically run the same thing. See, this is very powerful. It seems that 8-cylinder ones are only made in USA, and 3-cylinder ones are only made in Japan. Okay, so not surprising that I haven't seen a car, well, at least 3 cylinders. If you know it, let me know. I don't know a car with 3 cylinders or 5 cylinders. I don't know, what are they? So 5 cylinders are in Europe. I'm not familiar with them. And 3 cylinders are in Japan. Interesting. Okay. Okay, so the last thing that we're going to cover in Seaborn is regression plots. So let's quickly look at the data set again. So this is our data set. And this is very powerful. If you do LM plot, SNS LM plot, linear model plots, give me X, give me Y, give me data set. So this is our LM plot. And now I can play with the hue and with the hue as well. I say that, okay, give me linear regression. X is weight. Y is mile per gallon. Basically, I'm regressing mile per gallon and weight. Now, if I use hue is equal to origin, I will end up with 3 different regression lines for different countries of origin, right? So this is super powerful, right? So I can do something like this. Now, it is, for those of you who have taken econometrics course with me, this is as if I'm using a dummy variable for origin, right? So a dummy variable for origin. So it's 3 classes. I have to use 2 dummy variables, right? So I have to use 2 dummy variables, and basically US, Japan, and the third of them is going to be drawn from the model, right? Now I can see, I can look at the regression line using 3 lines, right? For different countries. Again, we do all these things in 1 line of code in Seaborn. Okay, so that's very powerful. And here's another example. I want to say that, okay, show me the regression line, but now only based in the columns are origins. So instead of showing them in overlay on top of each other, so just show them in separate columns, right? I can change these columns to rows. Not surprisingly, if I do row, I don't know, row or rows, we'll see. Well, it was row. Okay, so it's 3 rows, right? It's really straightforward. So let me actually Control Z, columns, and then finally, what else do we have? Here we're going to read again, we're going to work with the GDP data sets. Let's import it again. And let's look at the tail of it. So let's see what I'm trying to say here. Okay, I want to plot a time series. So in the next, I think in the next lecture, in our last notebook, I will talk about time series in a lot more details. So basically here, I just want to show you that if you want to plot a time series with Seaborn, you can do that. It's called line plot. If I do SNS line plot and then X is date, Y is GDP, well, I basically look at this one. Okay, so that was Seaborn. I hope you enjoyed at least being introduced to Seaborn library. This is a very powerful visualization library in Python. Let me see. Yeah, we can go to the documentation of all these packages. Actually, I'm going to go ahead and add one last cell into each of these notebooks and put the documentation for those libraries as well. For example, if I do Seaborn documentation, you can always find them on Google too, but so then you can see, for example, how we can do plots like this. So this is our pair plot, right? And so you see this is SNS per plot, the name of the data frame, and hue is a species. So this is a very famous data set. And we're talking about different species. And it's basically looking at a pair plot based on 3 different species. When it's come to classification and what other models in machine learning, you're going to see the power of this pair plot before running the model. So we get insight from visualization. All right. That's it. So there's only one last notebook, which I'm going to cover in the next video.